Hi, this is the demo of Project 3 of Distributed Operating Systems Principles submitted by Mugdha and Palak. Mugdha's UFID is 54219168 and Palak's UFID is 55510961. Now I will start by downloading the project from the e-learning website. This will take a couple of minutes. So let me tell you what Pastry is all about. Pastry is a distributed routing algorithm. It was developed by Microsoft Research Labs. It's a peer-to-peer object location system basically. So our job in this project was to implement the join and route algorithms like shown in the paper. Yeah, so it has been downloaded. There we are. I'll extract the folder right here. Okay, and we have our project here. We have implemented both Project 3 and Project 3 bonus. Our report is in the Project 3 files, and the rest of the files basically show our results and graphs in Excel format. Now I'll start a command prompt. And go to the folder. I'll also open another command prompt for the bonus part. Okay. So inside the Project 3, I will open an SBT. The SBT version, Scala version and Akka version are all specified in the project report. Okay. Now for our project, we have selected B, which is a very important variable in this algorithm. We have selected B as 3. So the length of our user ID and the length of the number of rows and columns in the routing table, as well as the number of entries in the positive as well as negative leaf nodes, is equal to B raised to 2 raised to B, which is 8. So our expected results are basically the total number of nodes divided by the log of total number of nodes to the base 2 raised to B, which is to the base 8, is the total number of average number of hops. So I'll just show you what I mean. I will publish both the projects, let them compile. Meanwhile, I would just like to show you what my expected results are. So here is a table of powers of 8. So if I have the total number of nodes less than 8, then my average number of hops should be approximately 1. If I have total number of nodes around 64 or less, then my average number of hops should be less than 2, between 1 and 2, that is, and so on. So for a total number of nodes less than 32,000, I should have less than or around 5 hops on an average. So let's see if it has compiled. Yes, they have both compiled. Now let me run the Pastry algorithm for you. The first argument is total number of nodes, which I have taken as 8. The second argument is total number of hops, Now you will notice from the paper as well as from the test that the average number of hops does not depend on the total number of routes. So here for 10 hops I have 1.2 average routes, which is like a little more than 1, so it is correct as expected. I'll just run another test for 100 nodes, and here I should expect I'll just increase this number to 5, and here I should expect about 2 point something average hops. So let's see if I get that. Yes, I'm getting 2.46, and we've been able to run this algorithm for 40,000 hops. I won't show 40,000 here, but I will show you around 5,000. So let's see, for 5,000 we should expect it to be above 4, right? Let's see if we are getting that. Yeah, this will take some time, of course. Yes, it has been initialized, and we are getting 4.48 hops. So now I would like to show you that the number of hops does not change even if I increase the number of routes. So if I increase this to let's say 10, initially it was 5, I made it double. So now it's routing, and it's approximately 4.47, so it didn't change much from the previous answer. Now let's go to the bonus part. For the bonus part, we have implemented, I would like to show you the code actually. So we have implemented the failure of one node at the moment. In my pastry actor, yeah, this is the part where we are handling the failures. So in the route algorithm, we find the next node, and before routing to that node, we just poll it in this line and check if the node is active or not. So here we have given a timeout of 1 second, and if the node does not reply with an ACK within 1 second, then we just assume the node is dead and remove it from our routing tables. So we have written two functions called handle failure and remove from tables just below that. Now in this code we are failing only one node, but we can extend this for many nodes by uncommenting the while loop, and it will work for many nodes. The reason why we are doing this for one node is in our computer we were having a problem with this timeout. So for 1 second timeout, this code runs correctly for only 10 nodes. I'll show you how. Main pastry, and I do 10 nodes, and I do around, let's say, 2 routes, and I've killed node 0.006, and yes, it gives me a little more than 1, which is expected average hops per route. But if I increase this to 100, then my timeout value is actually insufficient, and it will result in a wrong answer, as well as it will assume a lot of nodes have died. So I was expecting an answer about 2, but I got 1.9. So if I increase this timeout value actually, and do a publish local here, so I compile it again, and now if I run for 100 nodes, I have killed node 114, as you can see. Yeah, so I'm getting a value which is slightly above 2. So like the bonus part has been implemented, but the timeout value will be different for if we run on different machines. I think it's a problem with the internal network of my machine. Maybe it will run, it will give more accurate results on some faster machine, but this is what I have. So there it is. Pastry has been implemented, and the join and route have been implemented, and they run correctly without failures. And for failures of one node, if we manage to adjust the timeout properly, it run correctly, and we can extend that by we can handle the failure of many nodes by just uncommenting this while loop. So that is it for the Pastry demo. Thank you. I hope you enjoyed it.